Today topic is operator precedence parsing. An efficient way of constructing shift-reduce parsing is called operator precedence parsing. It is constructed from operator grammar. These grammars have the property that no production on right side is epsilon or has two adjacent non-terminal. That is right side में दो adjacent non-terminal नहीं होंगे और राइट साइड में एप्सिलॉन भी नहीं होगा. फॉर एग्जाम्पल ई प्रोड्यूसर ई ए ई और पेरेंथेसाइज्ड ई और माइनस ई और आई डी. ए प्रोड्यूसर प्लस और माइनस और इनटू और डिवीजन और दस पावर ऑपरेटर. Here three consecutive non-terminal have the grammar. So grammar can be written as follows. So this grammar is not operator grammar because its right side is containing three non-consecutive non-terminals. Operator precedence relations. There are three precedence relations. Less than relation. Here less than, between the less than there is dot. So this is less than relation. Second is equal to relation and greater than relation. Rules for binary operation. If theta 1 has higher precedence than operator theta 2, then theta 1 is yields to theta 2 in precedence and theta 2 is less than in precedence to theta 1. Second one, if operators theta 1 and theta 2 are of equal precedence, then make theta 1 is greater to theta 2 in precedence and theta 2 is greater than theta 1 in precedence if operators are left associative. Theta 1 is less than theta 2 and theta 2 less than theta 1 if right associative. So in case of equality, we have to follow these two rules if that is left associative and right associative. Third, make the following for all operators theta. Theta less than id, id is any terminal symbol, or id greater than theta, theta is operator. Theta is less than left parenthesis is less than theta, right parenthesis is greater than theta, theta is greater than right parenthesis, theta is greater than dollar and dollar is less than theta. Also make less than is equal to right parenthesis, left parenthesis is less than left parenthesis, right parenthesis is greater than right parenthesis, left parenthesis is less than id, id is greater than right parenthesis, dollar is less than id, id is greater than dollar, dollar is less than left parenthesis, right parenthesis is greater than dollar. You have to remember these relations. Now operator precedence parsing algorithm. First one is input, an input string w and a table of precedence relations. This will be given. Output, if w is well defined, then a pass t, otherwise an error indication. Method, initially the stack contains dollar, which denotes the end of a string, that is empty string, and input buffer the string w dollar. Here dollar is used to denote the string. First one, set IP to point to the first symbol of w dollar. Second one, repeat for reward. Third step, if dollar is on top of a stack and IP points to dollar, then return, else begin. Let A be the topmost terminal symbol on the stack and let B be the symbol pointed to by IP. If A is less than B or A is equal to B, then begin push B onto the stack. Next step, advance IP to the next input symbol, and this is end. So this will be repeated again and again. Operator precedence grammar. It is an epsilon-free grammar in which the precedence relations less than, equal, or greater than precedence relations constructed are disjoint. That is, for any pair of terminals A and B, never more than one of relation A less than B A is equal to B, and A and B is true. So for operator precedence grammar, out of these three relations, A less than B, A is equal to B, and A greater than B, only one will be true at a time for any two terminals A and B. Then we will tell you how to define leading A. This is equal to set of terminal symbol A such that A derives gamma A delta, where gamma is epsilon or a single non-terminal. Trailing of A, this is equal to set of A such that A derives, this plus means derives in zero step or more steps, gamma A delta, where dollar is epsilon or a single non-terminal. Example, consider the grammar E produces E plus T or T produces T into F or F produces parenthesized E or ID. Solution, E produces E plus T, therefore plus belongs to leading E. E produces T and produces T into F, therefore star belongs to leading A. Calculating in this way, we get leading of V is equal to plus star left parenthesis ID, leading of T is equal to star comma left parenthesis comma ID, leading of F is equal to left parenthesis ID, trailing of V is equal to plus star right parenthesis ID, trailing of T is equal to star comma right parenthesis ID, trailing of F is equal to right parenthesis comma ID. Following these rules, we can calculate this. This is very important. That's all about this today lecture.